The impossible floating chain fountain, defying gravity with simple physics. What if I told you a chain could spontaneously leap out of its container, defying gravity to form a magical floating arc? At first glance, this experiment looks like it breaks the laws of physics, but today we'll not only make it happen. This mesmerizing display is called the Cosmos Chain Fountain. First explained by physicist Steve Mould in 2013, it challenges our intuition about forces, showing how a simple metal chain can seemingly self-siphon out of a beaker and rise into the air before falling. The secret? A delicate balance of momentum, tension, and an often overlooked upward force. To recreate this, you'll need a smooth, flexible metal chain 1 to 2 meters long like a bicycle chain or bead chain, a tall container, glass beaker or jar, a lightweight surface to catch the falling chain like a plastic tray. Optional, high-speed camera to capture the action. 1. Prepare the chain. Coil the chain loosely in the container with one end hanging slightly over the rim. 2. Start the motion. Gently pull the dangling end downward, just enough to initiate movement. 3. Observe the magic. Instead of simply flowing out, the chain will rise upward, forming an arc before cascading down. 4. Adjust for height. Try varying the container as height. The effect becomes more dramatic with greater falls. The chain's bizarre behavior comes from 3 key forces. 1. Momentum. As the chain falls, each link pulls the next one downward, creating tension. 2. Upward reaction. Force. When a link is yanked downward, the container exerts an equal and opposite upward force on the chain still inside. 3. Curvature dynamics. The chain as stiffness causes it to pivot at the rim, redirecting some of the downward momentum into an upward surge. This creates a feedback loop. The faster the chain falls, the stronger the upward kick, making the fountain rise higher. Height matters, or the fountain effect disappears if the falling distance is too short, proving that it's all about momentum transfer. Chain type. Stiffer chains work better than completely floppy ones. Try comparing different chains to see the effect. Energy source. The fountain is in a perpetual motion. It is powered by gravity as pull on the falling portion. While this might seem like just a cool trick, the physics behind it has real uses. Space tethers. Understanding how tension propagates through chains helps design space elevator concepts. Ocean engineering. Similar forces affect anchor chains and underwater cables. Industrial processes. Conveyor belts and assembly lines rely on controlled momentum transfer. The chain fountain teaches us that even everyday objects can hide extraordinary physics. What seems impossible at first glance becomes logical once we unpack the forces at play. Try experimenting with different chain lengths or container shapes. Does a wider jar change the effect? Let us know your results in the comments. This experiment reminds us to question our assumptions about motion and forces. After all, some of the best scientific discoveries start with, wait, that shouldn't happen. If you enjoyed this mind-bending demo, hit like and subscribe for more experiments that turn ordinary objects into physics wonders. Next time, we'll be creating a vortex so powerful it can bend sound. See you then.